This video is going to look at another property we can use to solve triangles that are not right triangles. In a previous video we learned about the law of sines. We also learned that for the law of sines it only worked for angle-angle side or angle-side-angle triangles, meaning we had to know angle-angle side or angle-side-angle in that order. Today in this video we're going to look at the law of cosines. Now the law of cosines will work for triangles where we know a side angle side or side side side. Okay, so starting with a triangle that looks kind of like this, notice that there's nothing marked identifying it as a right triangle. And it is set up similar to the triangle we used on the law of sines. So for angle A, the opposite side from angle A is called a lowercase a. Angle B, the opposite side is called a lowercase b. And for angle C, its opposite side is a lowercase c. Now the law of cosine is all this you see wrote down below. And it looks very, very confusing and a lot of things to have to remember. But I'm going to try to give you kind of a more intuitive way to look at it. Let's say we wanted to find side A or angle A, either or. Well, if we take a squared, that will equal b squared plus c squared. Notice that this part right here looks an awful lot like the Pythagorean theorem. Okay? So whatever side we want to find, a squared equals b squared plus c squared minus 2 times c times b times the cosine of angle A. Kind of notice the pattern here. We start with A, we list B and C, and then we work our way backwards. 2 times C times B times the cosine of angle A. Alright? The same thing happens, let's say it's side B that we want to find. B squared equals A squared plus C squared, whatever the other two sides are, minus 2 times C times A times the cosine of angle B. Alright? For C squared, the same principle. C squared equals A squared plus B squared, our other two sides, minus 2 times B times A times the cosine of C. Okay. One other thing to notice though, although we are kind of working our way back out, these values are not squared. Alright, let's put this into practice on a couple of triangles. Alright, for this first example we have a side angle side as far as what we know. Side angle side. And in this problem we're wanting to find side G. So here's how we set it up. We're going to take G squared equals 15 squared, one of our other sides, plus 19 squared, another side. Okay, again, looks a lot like the Pythagorean theorem. Minus 2 times 19 times 15 times the cosine of the angle, 125 degrees. This is the angle opposite the side we're trying to find. Okay? Then we start simplifying. And I found that G squared would equal 15 squared is 225, 19 squared is 361, and this whole piece right here simplifies to 326.938. Rounding to 3 decimal places will usually be accurate enough. And I simplified that again. I did the square root, and I found that G was equal to 30.2. So, up here, instead of G now being an unknown, it is equal to 30.2. And you'll round it to whatever the problem asks you for. If it asks you for the nearest tenth, to the nearest unit, to the nearest hundredth, whatever it asks you for. Now, we could go about and keep finding another angle measurement. And on this one, I'm just going to set it up, and I'll show you on the second problem how to work through it. But let's say that we wanted to find angle F. This time we're finding an angle instead of a side. Well, our side opposite angle F is 15. So 15 squared equals 19 squared plus 30.2 squared. Notice those are our other two sides. minus 2 times 30.2 times 19 times the cosine of angle F, the angle that's opposite this side. Okay? And we would simplify and solve and use our inverse cosine to solve for this. And that's what we're going to do on the second example problem. All right. On this problem, I'm going to write this out this time, so maybe for some of you, if the first example didn't click, this one might help. I have this triangle, J, K, and M. I know all three sides, so I have side, 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 meaning we can use this law of cosines to find missing angles. So we want to find, in this case, angle J. All right? So since we want to find angle J, this part out here, the very first part of our law of cosines, is going to be 1.9 squared. Okay? Equals. Now we do what looks like the Pythagorean theorem. We're going to add both of those squares. So equals 1.3 squared plus 2.1 squared. Now we work our way backwards. We do minus 2 times 2.1 times 1.3 times the cosine of this angle right here. And they call it X. Let's call it J here just so we know which one we're going. That's our whole setup. Now we need to simplify. And I've done a lot of the calculations ahead of time. So 1.9 squared is 3.61 equals 1.3 squared gives us 1.69 plus 2.1 squared is 4.41. All right, and I'm going to multiply all this here together, so we subtract 5.46 times the cosine of J. Okay, we keep working to get the variable by itself, so I subtract both of these numbers, the 1.69 and the 4.41, subtract those away. We get negative 2.49 equals negative 5.46 cosine of J. Now, divide both sides by the negative 5.46, and we get 0.456 equals the cosine of J. At this point, we use our inverse cosine function, or arc cosine function, to solve for J. I punched that into the calculator, and I found that J is equal to 62.9 degrees. Equals J. So this up here, this is 62.9 degrees. Depending on what the question asks for, we could again use the law of cosines to find one of our other angles. Once we found two of the angles, though, then we can just use angle sum theorem. We don't need to keep working on those problems.